Hello, Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today's question comes from Tim Bandy, and it involves a lot of different things, so we'll take a look at them. Before we dive into this, I'd like to ask you to do me a favor. 1, click like. 2, leave a comment. Doesn't matter what the comment is. If you've got a question, leave a question. Otherwise, say, hi, this is from George KYZ3XC, or something like that. And if you do that, that actually is apparently where the YouTube algorithm is looking these days. Of course, you can subscribe and you can go to Patreon, but the thing I really would like today is if you just click like and leave a comment, however short. Okay, so let's see what Tim Bandy has to say. He is Tim Bandy, KR4LPL, in Baileyton, Tennessee. Now, that's a part of the country where it looks like some great big giant bear has scratched along the surface. You get a whole bunch of parallel hills and valleys, hills and valleys, hills and valleys. He says he got his license about 4 months ago, and he's about to finish his feed line and antenna setup. Now, he's a tech, okay? And my standard advice to anyone is that until you have the CSCE in hand, don't get any equipment or do any building or construction. Spend your time studying, okay? Now, he is starting to go ahead with getting set up for general, and that's great. I'm assuming he's going to take the general test soon. But here's the thing. He is looking at CW, wanting to do some CW things. He is says he's at about 12 words per minute on sending and is not near as good on receive. That is normal. That is normal. It is much harder to learn to receive the code than to send it. Okay? So there are a couple things you can do. Since you already have a radio, a TS830S, which will tune to about 7046 kilohertz. You can pick up the W1AW ARRL code practice sessions. And they start out at 5 and they go up to 5 to 10 to 15 to 20, 25 words per minute. And don't be afraid to try a higher speed. You'll pick out characters. You might even start to pick out words like the, da, dit, a dash, space, 4 dits, space, and a dit. And sometimes, when you get pretty good at receiving code, that just sounds like one word to you. So that's one way to do it. Another way that you can do this is to take a text, okay, any text, and send it into a recording. Use your phone to record it. Send it into the phone, the text, backwards. Okay, so start with the last letter in the text and go backwards. That way, when you are copying it, you won't be able to anticipate. It'll sound more like random characters. There's also software out there that I really like, but what I really want to tell you about is an organization called the Long Island CW Club. And that is longislandcwclub.org. Okay, all spelled out. And what they do, this is not some machine or some piece of software. You work with a human mentor, okay, in little groups. And they have got this fantastic setup. And there is a fee to join, not much. And they will work with you on an individual basis, helping you get your CW speed up. Now, as a tech, you have CW privileges on 80, 40, 15, and 10. You're limited to 200 watts, but you've got fairly wide swaths of the band that you can do that in. That does not mean you can do CW on any band, and note that 20 meters is not included. It's 80, 40, 15, and 10. Those are the old novice bands, and the tech has novice privileges, so you can work those in there too. So a rig like the TS830S is an excellent CW radio, both send and receive. It may even have a built-in keyer, although rigs from that era generally did not, but you can just use a straight key with it. It should have a side tone, and you can work from there. If you want to use a paddle, you'll need a separate keyer, but start with the straight key. Nearly everyone does. Okay, now there are some interesting things going on here. Now, he has a hill behind his house. As I told you, that area's got all these parallel mountains. It's about 60 feet tall. At the top, I can see over the nearest two ridges to the west. Now, you're going to get out pretty well okay either way. I'll tell you a little secret. On HF, you can put your antenna in your backyard, and you're probably going to do okay, because especially on 80 and 40 meters, because it just goes up and over the mountain and kind of hugs along for a while. Or you can do as you propose, which is to put your antenna up at the top of the hill, assuming you've got all the permissions that you need. Now, he mentions he has some 4-inch ladder line. Let me show you what ladder line is. I've got a piece right here. This is window line. You'll note here that it's got 2 parallel copper conductors, okay? And the wires are a standard distance apart, and you've got some dielectric material here, air here, dielectric material here, air here. And this is called window line for exactly that reason. Real ladder line is about 600 ohms characteristic impedance. This is 450 ohms characteristic impedance. And you can get or make for yourself ladder line that can be much lower resistance. For example, if you were to use just number 12 house wire, okay, 2 parallel lines, you put them about 6 inches apart, and every so often you have a little plastic spreader that keeps those things together, okay? Or you can get a standard 600 ohm ladder line. It's about that thick. It's bare wire. It has supports that keep the wire apart about every foot, which means if you twist it or something like that, you can really mess it up. But at 600 ohms, it's really good for long runs of feed line, okay? Now, in fact, I did some things to get the characteristic impedance, 276 log base 10, 2S over D, and the omega there just means ohms. Okay, that's the units. Now, the 2S over D is important. S is the center-to-center distance between the 2 parallel lines. Okay, and D is the diameter of the parallel conductors. If you use number 12 gauge wire here, this will work out to about 600 ohms if you go to 6 inches spread apart. Or you can take smaller wire, like 14 gauge, and go less far apart. Okay? Now, if you use the number 12, I also looked up the loss. Okay, at 7 megahertz, the loss is approximately 0.05 decibels per 100 feet at 7 megahertz, which is a good CW frequency. Okay, if you want to go up to, it says the thinner 14 or 16 wire will get slightly higher loss, but not much higher. Okay, and here's how to scale it for frequency. But the point is that you can have a fairly high SWR, and it will do fine. Now, he asks kind of a complicated question. The back of his antenna tuner, okay, has, in addition to the normal coax, that's an SO239, there's also something that looks like this with 4 things here. This is out for a long wire, and so then I think this would be ground if you're doing that. Or you can attach this to this and then take these 2 off as a, actually it's a 200 ohm output, because it's only a 4-to-1 balun in there. You can take it from there, and then on the front you've got the controls to tune the wire. I would recommend strongly that you want to keep the ladder line out of the house. And the reason for that is because if this is not balanced perfectly, it will radiate. And you want to keep that radiation out of the house. So if here's your wall and your floor, okay, and you got your desk set up here and you got your radio on top of it. I would do with your tuner, put your tuner up there. Okay. Now, the radio that you have, which is the 830, has a Pi network output. And so you can tune into a lot of different things. You may not need a separate tuner. Just 50 ohm coax. Take the coax out through the wall, bring it down to your lightning arrestor down here at your ground rod, okay? And then bring it to wherever you want to take it from and put the balun, which would be a 12-to-1 balun if you're using 600 ohm line, and then take your line from there. Now, the reason that I recommend that is because this is all coax. It's grounded right here. You keep any stray emissions out of the shack. And that's a good place to keep them. It's out of the shack. Yes, you can put wall throughs in there for your line. Yes, that does work. I tried at one point bringing the ladder line into the house, and I had a little double pole, double throw switch where I could either ground it or connect it to the tuner, and I had this attached to the back of the tuner. I had a horrible time with ARF in the shack. So I moved everything outside. Okay, so it's just coax inside. Of course, this is grounded too, which comes down to your ground also. Okay, so this goes out and this is balanced. And you want to keep it balanced going out. Now this is going to go a long way. It's going to go from your house in the valley up 250 feet up to the top of this ridge. And you were talking about putting in a dipole, end-fed half wave or something like that that would work. Now, you've got a choice. You can put in a balun here and go from 600 down to 50, put in a ground rod, connect that to the 50 side so it's unbalanced, or just leave it 50 balanced and then feed a dipole. Or for that matter, in end-fed half wave, if you want to do that, you are going to have to put a ground rod in here you're going to have to take it to 50 and then to the 49-to-1 balun, or put in a balun here that goes from 600 to 2400, which is a 4-to-1 balun, and then feed the end of the wire. Or another thing you can do to where you don't have to fiddle with balance at all is to create up here what's called a folded dipole. Now, folded dipole is where you take line like that, okay, and you string it, let's say 66 feet, and of course it's going to have little windows in it and so on. Now, this would be 66 feet for 40 meters. You come in the middle and break one side of that, not the other, the one side. And you bring your 600 ohm line in here. Now, if you use your 600 ohm line for this, you're going to get a feed point impedance that's close to 600 ohms. If you use 450 ohm line like this and you split it, say here and here, and attach it to the feed line, you'll end up with about 400 to 450 ohms. So you've got a good impedance match if you go to what's called a folded dipole. It's the same length as it would be otherwise. The ends are connected together. Okay, so it's a very squashed form of loop. Okay, and another thing is if you make this for like 40 meters, you will probably be able to feed it on anything above 40 meters, like 10 meters and 10 meters for your CW, or when you get your general class, whatever you're doing. Now, you will have to use that, you will have to retune the radio. Like I said, it has a Pi network. If you've got 50 ohm coax coming out of it, you can come pretty close to tuning it onto just about anything with that Pi network. Or, if you can find the 50 ohm point, get a 50 ohm dummy load, 50 ohm dummy load, short piece of coax to your radio, and tune it. Okay? Tune it. Now, take this away and feed this directly into your regular tuner. And then this is looking for 50 ohms here. And then you can take this wherever you want to out there. And of course, this is grounded, and this is grounded. And the nice thing about this is you know you've got the thing tuned for 50 ohms out, which is the input impedance for the tuner. Okay? Now, that's a thing about these old radios. It's got a tube output. These radios, there was about a 20-year period when all the radios back then, such as the Yaesu FT101 series, the 201, the Kenwood TS520, and the ICOM, I don't know what theirs was, but these all had all transistors except a driver tube, which glowed in the dark, of course, and 2 finals with caps on them. I believe the Yaesu drove these in parallel rather than push-pull, which was simpler, okay? And they put out a good amount of power. You have to be very careful if the output tubes are what are called sweep tubes. These were used by old color television sets to sweep the electron beam across the screen. And they will put out, 50 to 75 watts each, but you need to be extremely careful with them because if you tune them wrong, you can flatten the tube in a hurry. And they're expensive. Matched pair is about $50. And this is the driver tube, which just is an ordinary tube. Now, Kenwood, I believe, used actual formal transmit tubes, which were designed for transmitting HF. So these will have stronger tubes in there. By the way, my Yaesu FT101B still has the original sweep tubes in it, and it works just fine. It was very well cared for. Okay, but that's where you run into that problem with using an external tuner. Almost all tuners these days have got this schematic. They come in to a tunable capacitor, which comes to a coil, which is connected to ground. That's tunable, and then come out through another tunable. And this is known as, this isn't a Pi network. Pi network looks like this. It's got a coil, and then it's got 2 capacitors, which you can adjust to get down to here, and this one is adjusted by the band. You don't do anything further with it. This is the Pi network, and if you're going to feed this right into a T network, like that, you want to pre-tune this as 50 ohms right there. And then this will be whatever it is. This will go out to your balun, your 12-to-1 balun, and then that will go to the 600 ohm ladder line. Why 12-to-1 balun? You've got that part right. And I'll show you. You want to do an impedance match. If you have a balun that is designed for 50 ohms here and 600 ohms here, the ratio between the two is 12, okay? So it's a 12-to-1 balun. Now, 12-to-1 can be a little hard to construct because the impedance output is the square of the turns ratio. So if T is the turns ratio, you square it to get the factor that you multiply the impedance by. So you multiply here by 50, T squared, you get a number of turns that is not an integer number, and you want an integer number of terms. So you're going to have to get close, something that is close to that, okay? So there you go. You've got something that you can do. Now, the loss in 600 ohm line is very low. It's a little bit higher at 30 megahertz, but that covers the entire HF band. Can you ship VHF over this arrangement? Absolutely you can. Okay, so I recommend you keep your balun outside. 250 feet from the house is not bad, but you're going to have to hold this thing apart from whatever it is that you use to hold your line up in the air. Because that big, the wave pattern around it is pretty good sized. Okay, now, I told you different ways that you can learn Morse code. I recommend the Long Island CW Club. Note that it is much easier to send than receive. And by the way, when you send, you remember I said to send into a recording and to take the letters in reverse order because they sound more like random characters when you do that, making it harder to anticipate. Anticipation is my downfall. I'm anticipating one letter and I get another and it throws me off, and I'll lose several characters in a row. The folded dipole up at the top will be a better impedance match to what you're trying to do. So I hope that helps you. Device between the ladder line and the dipole. I'd go with the folded dipole. And do you need a common mode choke? No, because you're going balanced to balanced. So you don't want a common mode choke because you're balanced to balanced. Stay balanced all the way through. You only need the un if you're going from balanced to unbalanced or unbalanced to balanced. Okay? So there you go. So, Tim, there you have it. I would suggest that you get to work on your code, and you can use your tech license for the code, and you'll find it to be very interesting, okay? It's easier to learn to send than receive, so work on your receive. Also, if you put those characters into the tape or the recording backwards, you'll be able to see if you can read your own code, okay? I have lots of problems with people learning to send code for the first time. They tend to make the dits and the das about the same length. And that is not what you want to do. I actually forced myself so hard that when I send with a hand key, my dits are only about 1/6 as long as the das. They're supposed to be 1/3 as long. So there you go. You can get straight keys from MFJ. I think Chameleon might carry them now. There's a place called cwmorse.us where you can buy keys and that are quite inexpensive, okay? And I've got a couple of them. In fact, I've got one right here. This is a cwmorse.us key, and it's a straight key, okay? And you've got a jack in the back that just takes a regular 3-conductor line to go to your radio, okay? 3-conductor audio cable. And there you go. I also, that same company makes paddles. And they put them on these nice heavy aluminum bases so they don't go skating all over the place. And there are lots of keys. You could do several videos on keys. Okay, so if you've gotten this far in the video, I would ask you to do me a favor. And that is like and leave a comment. It really helps if you like and leave a comment. Like is really easy, doesn't cost you anything. And the comment can be anything, like, "Hi, Dave," or "My name and call is so-and-so." Put that down. Or you can say, you know, when I learned the Morse code, I had the best luck with this. For me to learn the Morse code, I ended up having to get a sending buddy who would send code to me, physically send it to me, and I'd hear the buzzer, and I would copy the code. And that's the way I did it. And this guy, who was a roommate, he wasn't real happy about this, but he did it. He learned to send about as fast as I learned to receive. So that was good. It worked out really well for me. I took my first code test at the BYU Amateur Radio Club, and second code test at the FCC office in Los Angeles. You had to go down to the FCC office in those days to test. They had a machine that sent it. It one with the running tape. It was the sweetest, most wonderful code I ever heard in my life. I've never heard better code. And then I took my 20 word per minute at the Boulder Amateur Radio Club Junior Division when they were having a testing day. Now you don't need to do the code at all, and so it becomes kind of a special thing to learn to do code. So I'd love to see you on the air. Let me know when you get set up and you're willing to do a CW conversation. I'll get on the air with you for that. So until we next meet, 73.